Good morning, everyone. In this video, we will discuss what is ADC and what are the methods that is used for conversion of analog signals to digital signals. So first, we must know what is analog signals and what is digital signals are. So first, analog signal. Analog signal is a continuous signal in which one time varying represent another time-based variable. So it represents, or this kind of signal works with physical values and natural phenomena such as earthquakes, frequencies, uh, speed of light, speed of wind, lightning, weight, and etc. But on the other hand, digital signals is used to represent data as a sequence of separate value at any point of time. So this kind of signal represents real numbers 0 and 1, or what we call binary numbers. So all in all, analog signals is more suited for audio and video transmissions, while digital signals are suited for computing and digital electronics. So, what is ADC? It is a short term for analog to digital converter. So, from the word itself, converter, it converts, or it is a system that converts analog signals such as human voice picked up by a microphone, or light entering a camera, or a frequency that has entered a black box into digital signals. So the most specialized ADC are implemented as ICs, or integrated circuits. So as I have said earlier, this video is about methods that is used in AD conversions and their differences. But there are plenty kinds of methods of AD conversions out there, so I'm only giving two types of methods. Okay? Which is the PCM and PAM. Okay? So, what is PCM? So, this is a common method of conversion. So, PCM is used to digitally represent sampled analog signals. It is the standard form of digital audio in computers, digital telephony, CDs, etc. So, in this method, there are three steps or processes as you can see in the whiteboard. So, here's the analog signal, the chart, the frequency of an analog signal entering into PCM encoder, which is the whole of that, the sampling, the quantizing, encoding. After the analog signal entered, the signal entered in the PCM encoder, the sampling selects the data points that is used to create the digital data. So here are the points. I hope you can see. So the frequency wave of AC was converted into this. So another process is quantizing. So after the sampling, the frequency that has been through sampling Quantizing, it chooses to amplitude values used for encoding. So, after going through a quantizing, the frequency will look like this. So, after that, it will go through the encoding. Then the encoding assigns binary numbers to those amplitude values that so it will turn out to digital signals. That is how the flow of AD conversion of PCM. Okay. Now let's talk about PAM. PAM is a basic form of pulse modulation in this method. Uh, the amplitude of each pulse is controlled by instantaneous amplitude of the modulation signals. PAM is a modulation system in which the signal is sampled at the regular intervals, and each sample is made proportional to the amplitude of the signals at the instant of sampling. This technique transmits the data by encoding in the amplitude of a series of signals pulses. This is commonly used in Ethernet communications, photobiology, driver for LED lighting. So, the signals can transit into a longer distances. So that is the difference of PAM and PCM modulations.